All right, my friends, welcome back to another episode of Build Science
201.
Thermal Control, our final episode in this series. What are we talking about, Steve?
Proportional.
All right, guys, let's get going.
Build Science 201 is sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco. This episode is brought to you by Rockwool.
Hi, everyone. I'm Matt Reisinger, and today I want to talk to you about a brand that has a remarkable 120-year legacy in producing quality, performance-focused products. That's Anderson Windows. In the South, especially here in Texas, that legacy really comes to life with the Anderson 100 series. Gosh, I think I started using this line when it very first came out, and from the beginning, I have really liked this window. This line enables you to choose dark colors without sacrificing performance. That's right, style that doesn't compromise on quality. One of the key features of the 100 series is Fibrex, Anderson's proprietary material. It's actually 2 times stronger than vinyl, which means you won't experience flex over time. Your weather stripping stays tight, and that's going to ensure that both air and water performance, water holdout that is, remain top notch. Now let's talk about performance enhancements. Anderson is expanding their triple pane offerings, which is a fantastic option for energy efficiency. You can find triple pane windows available in the A series, a FIAS certified E series, and now even in the 400 series at select locations. So whether you're looking for style, strength, or energy efficiency, Anderson has you covered. With a commitment to performance that you can trust that these windows are going to stand the test of time. Thanks for joining me today, and if you're considering new windows for your home, definitely check out Anderson and see the difference for yourself. Steve, come on. Look at that beautiful house.
This is a project I did with Shoreline.
I've been there.
Jim and Taylor.
Gorgeous.
Been out here. Today's topic, being proportional. I'd love to tell you, everything about it, but Building Science Corporation did a great paper on it.
Yeah.
Right? And basically the concept behind proportional is that we have our 10, 20, 40, 60, and 5. And what we're talking about here is sub-slab, wall, foundation wall,
Yep.
above grade wall, roof, and windows.
So these are our values that they say are where we should start. Of course, you can go higher than that, but they wouldn't recommend going much lower.
Right.
And those are pretty high values for the South.
Yeah, this is probably more climate zone 5 oriented.
Yep. But I would say also that I met those values in a lot of places in my house. I moved into a high performance home 2.5 years ago, Steve. Used a lot of your methods that I'd seen you use. Used some products that frankly are more common to be used up in Boston, including some triple glazed windows and things like that. And I got to tell you, the payback for me, I get every single day in comfort and enjoyment of my house.
Yeah. And the key to today's episode is these numbers are here and they're somewhat proportional, right? It wouldn't make sense to come here and say, do R20 sub-slab and then do an above grade wall at R21.
Right, that's right.
That wouldn't make sense. Or to do, instead of R5 windows, do an R3 window when our above grade wall is, say, R60.
Yeah.
Right? They just don't make sense. So
That's
being proportional is about making decisions so that the whole house is working together thermally.
Yeah, because ultimately, when it comes to thermal, heat doesn't know where it's going. It's going to go through the weakest link in your house, and especially a house like that we're building today that are more modern, they have more glazing in them. We need to be more cautious. If you're building a house that's very high on floor to wall ratio for glazing, then we really need to think about going to those higher numbers for glazing and using better glass in our house. Yeah. I think that we should be thinking about these numbers no matter where we are building in the United States. Okay, so basements. We're going to work our way up on the house.
So we're starting in the basements, right? So we have 2 inches here. This is roughly R8.
Yep.
It turns up the corner. This block here, this is probably somewhere around R16. Where this house goes a little wonky, this is a passive house. So our above grade wall is is probably somewhere around R48.
Oof.
So yeah, we're gonna step it up a little there, but you can see how it basically grows, right? Grade is probably somewhere right in there.
Mm-hmm.
And down here, our delta across the slab, we're probably a 15-degree delta at best.
All right, so if the ground's 55, let's say, or 50, it's 65 in the basement, so there's a 15-degree delta.
Exactly. And then along the wall is a little different in that the wall is probably something like that, right? Depending on grade. The delta down here being that 15 degrees, but up here it could very well be 70 degrees plus, right? So that delta changes. So we want a little bit more R value there. And of course, above grade wall, it's pretty much the whole wall could have that delta of 70 degrees plus.
Yeah, meaning you're heating your house to 70 in the winter, but it's 0 degrees outside. Makes a lot of sense to have a thicker insulation value, that R48,
right,
above grade. This is where that proportional comes in.
All right, so this is a good place to talk about the makeup of a wall and the U values of the wall, not necessarily the R values. And the reason is it's the same explanation that we chatted about when we talked about the window, right? In this wall system, we have an R value across the stud, we have an R value across the cavity, and we have an R value across the window.
Yep.
All three of those are different.
Yeah.
And so if I want to calculate what's called the whole wall R value, then I need to understand what those three are doing, right? For example, on the wall here, we might have R21 for our cavity, and then on this house, we did an R6 on the outside. So our total there is an R27 on the wall. The windows here, these were roughly around R5. And the stud here is roughly about R6, right? And at 24 inches on center, we talked about that, right? So the whole reason of pushing to 24 inches on center, I've actually counted studs and did a bunch of studies when I was at Building Science Corporation. So in a typical house, the framing factor, or what I would call the opaque area, which is if I took all of the areas on the studs and I put them all together for the house, that would make up probably somewhere around 18 to 20% of the wall system.
Of the total square footage of the wall.
Total square footage of the wall.
Okay.
The windows here, and we'll call this A, the windows at B, those account for 20% plus or minus.
Yep.
Right? If you're building a house on the coast or on a lake down here, you're probably going to, that numbers might be 25, 30%.
Sure.
Right? And then, of course, the cavity, which is C, is, let's say, that remaining 60%. Right? Now, those numbers that I showed you there, this is for a 2x6 wall at 16 inches on center. And when you do the calculations across that wall, even though we would want to call it R27, I'm guessing it's probably somewhere around R12 for that.
Wow.
Yeah,
quite a bit of a
loss. It drops quite a bit because the windows are bringing it down. And I should say, for the windows here, we're using an R value of R3 on those windows. So if we bump it up to the R5, or if we bumped it up even further to a European version, we might get R7, R7.5. But the reality is that 18 to 20%, if we move to 24 inches on center, we could probably get that number down to about 14%. And if we're really good, we can get it down to maybe about 12%.
Wow, that's pretty good.
Yeah, so we get that, let's say 6 to 8% shift. The windows we can't change, but that shift goes right into this, and now this becomes 68%, right? And that the minute we add R sheathing on the outside or upgrade the windows, that brings that R12 up rather significantly.
Yeah, it does.
Right? And that's the purpose for using the continuous insulation on the outside of the wall
Yep.
is that this R5 is also getting the R6. So it's really R11 at that stud there.
Yeah, that's right.
Right. And when you're talking to Delta, like I said, you know, and those of you that aren't familiar with Delta, we're basically just talking about the difference in temperature,
Difference between,
the outside and the inside, where the inside, we want it to be 70 degrees. Well, in September, that might be the truth. But in the wintertime, this could very well be 20 degrees out here. And in the heat of the summer, this could very well be 100 degrees.
Yep.
Right? So we're battling that delta. So this one here, this is just a really simple shot of blown mineral wool. There's a lot of insulations out there that understand whether I'm using, say, an open cell, mineral wool, fiberglass, cellulose, wood fiber. All of those insulations are probably somewhere between 3.8 and I would say maybe 4.2 at best. So when people come at you or the builder says, well, I use cellulose.
That's R value per inch.
And this is R value, yes,
Got it.
R value per inch.
Now, wouldn't closed cell foam be higher than 4.2?
Well, closed cell, but I didn't list closed cell there.
Gotcha.
Right? Closed cell is, I would use that as probably something around 6.5 per inch.
There you go.
Right? But
Gotcha.
a lot of times you hear, well, I used open cell because it's a much better insulation. No, it isn't. It's really not any more R value
Right.
than fiberglass or blown fiberglass or cellulose or all the ones that I listed.
That's right.
So you really have to make sure that you're checking on what these numbers are so that you really understand what you're doing.
Yeah, that's right.
So in this one here, this is, I felt compelled to just throw up an insulated wall. This one's a little different because we have this upturned beam down at the bottom, but this is a typical cellulose wall. We're at 5.5 times 3.8. We're probably in that R21 on this wall, but we also have the R6
On the
outside, right? And the windows here, this is a domestic window here. This is around R3. So, this is what I would consider a really good house in our climate zone. I mean, these things are built maybe minus the R6. It's a pretty typical build to meet the code level that we have there. Certainly not exceptional, but it certainly does provide a really good house.
Now, Steve, when you go into the basement, you talked about those above grade values being higher. I think it's interesting as we're talking about proportional insulation. We don't have a great difference or a great delta between the Earth's temperature and the basement temperature, so we don't need quite as much insulation. It doesn't make sense to put an R40 down there or some giant thick insulation blanket. So this looks like it's maybe 2 inches of EPS. This could be probably R8, somewhere around there in that basement slab, which would meet our expectation of proportionality when it comes to thermal transfer.
Yeah, when you get into a range where the delta is only about 10 degrees, right? Ground being 55, room being, say, 65, then you're really talking about comfort there rather than thermal resistance. I mean, granted, it's insulation, it's stopping it. But what we're really trying to do is maintain a level of comfort down in that basement and making sure that we get that thermal break up against the wall so this cold foundation wall isn't touching our slab.
That's right.
This one takes us back probably about 14 years.
What are we looking at
this
here,
is
Steve?
a floor
Orient
system
me.
for a passive house. This was the very first passive house I did. And I know I always talk about the house on the shore.
Okay.
Getting awarded my first passive house. And this was in a time, let me set the perspective, when there was probably 3 passive houses in the country that were built. And they were all built by Katrin in the Chicago area.
Holy cow.
So I said, we could build you and we'll make it a passive house and get it certified. And then I was like, on my way home, I'm like, now I got to figure out how to build a passive house. But I remembered Joe's talk where we were talking and he had a drawing of a double wall, right? Where we had a couple studs sitting on the floor. And he basically just rotated the drawing. So now it was horizontal, right? And said, Mother Nature really doesn't know the difference between a vertical system and a horizontal system, right? Heat moves from hot to cold.
Yep.
It doesn't care whether it's vertical, horizontal. I mean, there is
True.
a little concern about, stratification and all of this stuff, but in general, Mother Nature doesn't care.
Yep.
So in doing that, you can see we're prepped here for a double wall assembly. I thought, why don't we just do a double floor joist assembly?
Huh.
So we have our XPS. This is furred up about 16 inches. And we put the insulation there because if you remember in our vapor talks, we talked about controlling condensing surfaces.
Yep.
So I put the rigid insulation down there to warm up the slab.
Okay.
And then on top of it, we blew in 16 inches of cellulose.
Oh, fascinating.
And then we billowed it so that we knew we were going to screw down the subfloor, and then that would compress it and we'd get a really good density down in there.
Wow, that's wild. So that's a subfloor on top of a slab on grade house, let's say, that you totally thermally broke.
Yeah, and it's probably on the order of about an R70 floor assembly.
So back to the proportionality then, why go R70 on that floor, but not on the basement floor on the previous one?
Because we have our double wall up here that is pretty darn close to that same R70. And then in the roof system on this house, we blew in 24 inches of cellulose, which puts us in probably somewhere in the R80 plus range.
Got it.
So, and it's a passive house certified house, one of the very first in the nation.
Okay, that makes sense.
So proportionality, again, it doesn't mean that you only do this. It's that all of the steps are just proportional to each other.
So 20 on the floor, 40 plus on the wall, 60 plus on the roof. It's still proportional.
Exactly.
Okay, that makes sense.
In the previous episode, I talked about how we used an XPS on the outside, but here we basically have a pocket. And I really like this detail. I call it a pocket header. And the beauty of that is when the insulator comes to insulate this cavity, they insulate that pocket.
Ah, got it. So whatever you're using the cavity, whether it's bats or blown in, that same cavity up there can be
that can get the same
insulated
thing.
as well.
Or if we're blowing in a closed cell to seal up our roof baffles, we could just do closed cell in those pocket headers there.
Smart.
And then the framer isn't working with XPS or just materials that he doesn't want to work with.
That's really smart.
Right. And going up to the roof, how do we get proportional in the roof system? Well, up here you can see we have what's termed a raised heel truss.
Mm-hmm. The heel meaning the end of the truss that sits on top of the wall. You got your double top plate right there.
Dimension.
The heel sits down on top, and on my 70s house that didn't have that, I basically just had a 2x4 top cord and a 2x4 bottom cord landing down on the top. So I was only able to, at my house, when I re-insulated, I was talking about that earlier, I've only got a couple of, let's say, 4 inches of insulation above that double top plate, whereas you're going to be able to get 12 or more inches.
Yeah, we're probably at around 12 inches here. So we give up a little to the vented roof, but that still yields about 10 inches of insulation there.
That's really nice.
Right? As opposed to the detail you're talking about is you get just that 3.5 inches.
That's right.
And if you're in, say, a climate zone, let's just say high 4s and above, and you see ice damming on the outside,
It's probably that.
a lot of it has to do with that because this wasn't done.
Yeah, because the heat is able to transfer through there. So on a cold day outside, the heat from the house transfers through that real thin amount of insulation on that non-raised heel. The ice that's, or the snow rather, that's on the roof starts to melt and it becomes an ice dam. Steve, for many years when I first started building in the South, I realized, look, I need to bring my ducts into the conditioned space. And so I was utilizing open cell foam into the attic space. But to be honest, I think that codes are a little lagging when it comes to how much insulation we should have in our attic space. And so we were only spraying at times, 6, 7, 8 inches of open cell foam into the attic. And in checking it back with homeowners, I felt like my attics were gaining more heat in the summertime than I felt like they should. And so these days, a lot of times I'll say, look, forget about what code says. Let's insulate it to the right value, especially for my southern friends, right? I think sometimes our codes are lagging behind, and you'll also notice in many parts of the country, you might still be under a code that's 10 years ago when it comes to the International Energy Conservation Code. So of course you need to build your house to code, But remember, code, especially when it comes to insulation, is the minimum value to build a legal house. And that's not necessarily the right thing for the house or for your homeowner or for you as the builder. So these days, I'm typically telling builders, especially in my climate zone, I'm in climate zone 2, look, we should be thinking about doing somewhere around 1.5 to 2x what code calls for, especially in your roof. You know, in Texas, you see a lot of cowboys in the old Western movies wearing a big sombrero. It's because that sun beats down and gets really hot. And so when we talk about proportionality, for me, I want to see a big amount of insulation in that roof. We're fighting the sun's heat and the gain that happens on the roof. So depending on what code is, consider going a lot higher. Just because it says code is whatever, R30, doesn't mean you have to do that. You can always go more than that.
Yeah, and you know, one of the things I wanted to throw out here, if you didn't catch it in one of the earlier episodes, Peter Yost and I were in a Houston attic. The outdoor temperature was 104 degrees.
Mm-hmm.
The inside attic was 165.1 degrees.
Now that was a vented attic, right?
It was a
traditional
vented attic, but all the ductwork was up there.
Yeah.
Right. 165 degrees. I think
That's
I lost
crazy.
10 pounds just hanging out up there for like 5 minutes.
This attic for John and Becky, my clients, when it's 104 degrees out, that attic probably doesn't get any hotter than about 78 or 79 degrees when their thermostat is set at 72 in the house.
Yeah.
And all that ductwork is running through a nice conditioned space. So think about the service tech that's going up to service that equipment, to change filters compared to that house that you were in that was 165.
Yeah.
I can't imagine those poor service techs having to go up and work on equipment in attics when it's hot like that. That's crazy out.
So how about all of you builders? I'm gonna give you a little challenge. This time of year, let's say August 15th, on a nice hot sunny day, wherever you are in the United States, close all your windows, do not turn your AC on for the whole day, and just ride around in your car. And maybe that'd be a little reminder to what's happening in the attic.
Yeah, that's right.
I'm going to quote a famous opening line to a book. It was the best of times, it was the worst of times. Not because of the slide, but I really enjoy your company. I really enjoy doing these Build Science series. And unfortunately, this is the last slide of the last episode.
Dang, I can't believe we made it through. It's my buddy Andrew at my house putting in that rock wool to finish off that insulation. Steve, this has been an amazing series. As we finish off the thermal control layer, I just want to make this point again. We've said this in other episodes that the order of control layers is super important. We've got to go back and make sure that everything when it comes to water is on point for our houses. Forget about thermal control. Build it to code if you need to, and that's it when it comes to thermal. But first, get your water right. Then get your air control layer right. It's the very next thing we must do after we make our houses waterproof. Then we're going to deal with vapor and make sure we get that correct. And then these episodes that we talked about with thermal, then we're going to get our insulation right. Steve, it's been an amazing series. Anything you want to wrap up with here?
No, I think you nailed it. And like I said, best of times, worst of times. But we do have something to look forward to.
We do.
Build Science 301, and we're doing that live.
Yes.
You definitely want to come and see Matt and I talk 301 all day.
Build Show Live, November, Austin, Texas, 2024. It's going to be amazing. And we're going to be filming 301 as well. So if you can't make it, don't worry. We will have 301 out for you in the not too distant future. But with that being said, go follow Steve on Instagram. Go watch his videos on thebuildshow.com. This has been Build Science 201. We'll see you next time on The Build Show.
This episode was brought to you by Rockwool. Build Science 201 is sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco.